Hi, and welcome back to the Enclosure Institute. I'm Jimmy Budd.
And I'm Phil Taylor. Today we're going to be a couple of storytellers. We're going to share a real-world application for an enclosure whose seal was failing and discuss how the proper solution was achieved.
Our customer is a designer and manufacturer of critical electronic communication systems for healthcare and educational institutions. Their product and service enables the hospital or education staff to quickly and efficiently communicate to request assistance, initiate workflow, start emergency procedures, or simply record the status of tasks, set audio, music, or make announcements to all or select zones in the building or the campus.
Among other things, the system includes wall-mounted user interface stations with easy-to-use touchscreens that are used by authorized staff. These relatively small interface stations are molded plastic electronic enclosures, and they're installed in many convenient locations inside the building or in multiple buildings in the hospital or the school campus.
The enclosure was designed, of course, with the gasket and the molded plastic housing to keep moisture and debris from contaminating the electronic hardware inside. The original gasket was made of a closed-cell neoprene sponge that was installed beyond the LCD touchscreen and compressed by the plastic housing. The neoprene foam gasket contained a layer of acrylic PSA on one side that was bonded to the plastic housing during assembly. Within months of the first installation of these interface and intercom stations, the customer began to receive notices of failures of their internal electronic functions. Their investigation quickly identified the problem as moisture ingression.
In spite of the fact that these units are exclusively installed indoors, moisture was getting behind the seal and contaminating the electronics within. In the hospital environment, where these screens are touched frequently by multiple and various caregivers, protocol requires very frequent cleanings. The cleaning process for these units included a liquid spray of antibacterial agents propelled in a water-based solution. During these cleanings, enough of the moisture from the cleaning solution was penetrating the gasket and causing the electronic functions in many of these units to shut down. This is when the customer reached out to Marian for recommendations for potential solutions.
After material evaluations and prototyping, the ultimate solution was to create an assembly which involved the stack up of 3 materials in 4 layers with the addition of a pull tab to aid in final assembly. The first step, and perhaps the most important, was the foam selection. It was determined that Rogers AquaPro Pour-On Foam in formulation 4701-41 in a 30-pound density and 45 thousandths thick would provide a watertight seal when compressed at least 30%. This grade of pour-on foam is relatively soft and easily compressed, and its microcellular structure further enhances its ability to achieve a moisture-tight seal. The problem probably would have been solved by simply swapping out the failing closed-cell neoprene sponge with the AquaPro Pour-On Foam.
But to improve the overall product design and function, the Marian team suggested the addition of a cover for the LCD screen made from Autotech's AMF microban antimicrobial film, a surface protection material that would prohibit bacterial growth. This film combines a unique UV-cured hard coat technology for durability and chemical resistance with antimicrobial technology that inhibits the growth of bacteria on the surface. This was not added to eliminate the need for frequent cleanings, but it was meant to further restrict the potential for the spread of bacteria. The film covers the full surface of the LCD screen, while the foam gasket encompasses the screen, sealing the entire enclosure.
Marian laminates the microban antimicrobial film over the top of the AquaPro foam gasket with 3M 9832 Plus high-bond acrylic double-faced adhesive. In this way, the antimicrobial film covers the LCD screen and is tightly sealed to the AquaPro foam and the plastic housing. An additional layer of 3M 9832 Plus was also added to the bottom of the foam and covered by the protective liner. The customer removes this liner when installing the gasket assembly into the housing, giving the gasket a tight bond to the plastic housing.
The final piece of the solution was the addition of a pull tab on the temporary protective mask covering the antimicrobial film. In order to protect the film surface, the mask is not intended to be removed until the final assembly of the user interface device. To facilitate a quick and easy way to remove this masking layer during assembly, we provided a pull tab of white polyester with a high bond PSA laminated to the mask that allows for easy removal. This is another example of what we call design for manufacturing. The masking layer and the pull tab are not part of the final assembly, but they are part of the solution in order to provide the customer an efficient method of assembly.
We prefer to interface with our customers during their earliest design phases. When doing this, we have the best chance at guiding your design in the right direction from the start. That said, we don't mind being called into action when an existing design is failing in the field. We understand in these situations that time is critical. We're ready for that challenge with the support of Rogers and other outstanding material suppliers, many of which we maintain preferred partnerships.
In general, when working with a converter like Marian, you're saving yourself a lot of headaches. The value that a converter like Marian brings to your design team includes the in-house engineering, quality, and technical staff that we make available. And it also includes the vast array of proven material suppliers like Rogers Corporation and all of their technical support.
Yeah, and what helps both Marian and Rogers win in applications like this one is our technical expertise, our capacity, and our global footprint. Both Marian and Rogers have facilities and representatives near you no matter where you are in the world, allowing us the ability for rapid turnaround on sample material, prototypes, and even first production.
In this example, we were able to make laser-cut prototypes within 24 hours to allow the customer to begin testing overnight. Testing with positive results took less than a week, and first shipments went out shortly thereafter.
Not to pat ourselves on the back, but we're pretty good at what we do. Some may even say the best. Well, that wraps up the content for Module 2 of the Enclosure Institute. In Module 3, we'll talk about some of the cell structures of foam, static and dynamic gasket applications, the stress caused by outdoor applications, and the need for long-term gasket sealing. So be sure to tune in. Until then, I'm Jimmy Budd.
And I think I'm still Phil Taylor. I'll double check before next time. So long.